A haloalkane molecule is formed when a hydrogen atom in an alkane molecule is replaced by a halogen atom. Some typical haloalkanes are illustrated here. This class of compounds is also called alkyl halides. Haloarenes are formed when a hydrogen atom in an aromatic compound, such as benzene, is replaced by a halogen atom. These compounds are also called aryl halides. Many organic compounds that contain halogens occur naturally. Both synthetic and naturally occurring halogenated organic compounds have important uses in medicine and research. Chloramphenicol is a naturally occurring substance produced by soil microorganisms. As you can see in the structural formula, it contains 2 chlorine atoms. Chloramphenicol is used as an effective drug in the treatment for typhoid fever. The thyroid gland, a butterfly-shaped gland at the base of your neck, produces the hormone thyroxine. Notice the 4 iodine atoms in the chemical formula. A lack of dietary iodine can lead to a deficiency of this hormone, which can eventually lead to goiter. Many countries have mandated that small amounts of iodine be added to table salt to minimize the risk of goiter. Chloroquine, a synthetic compound, is used for the treatment of malaria. Halothane is used as a general anesthetic during surgery. These compounds are used in industries as solvents for relatively non-polar compounds, and also as starting material for the synthesis of a variety of organic compounds. Haloalkanes and haloarenes can be classified in several ways. One way is to classify them based on the number of halogen atoms. Chloroethane, a monohaloalkane, and chlorobenzene, a monohaloarene, each containing 1 halogen atom, are shown here. Dihaloalkanes and dihaloarenes have 2 halogen atoms in their formulae. Trihaloalkanes and trihaloarenes with 3 halogen atoms are also known to exist. Based on the hybridization of the carbon atom to which the halogen atom is bonded, monohalo compounds are classified as alkyl halides, allylic halides, benzylic halides, vinylic halides, and aryl halides. In alkyl, allyl, and benzyl halides, the halogen atom is attached to an sp3 hybridized carbon atom. On the other hand, in vinyl and aryl halides, the halogen atom is attached to an sp2 hybridized carbon atom. We'll start with the alkyl halides, or haloalkanes, which have the general formula Rx. R here represents an alkyl group. In these compounds, the halogen atom is bonded to an sp3 hybridized carbon atom. The homologous series of alkyl halides can be represented by the formula CnH2n plus 1x. based on the nature of the carbon atom to which the halogen atom is attached. The alkyl halides are further classified into primary, secondary, and tertiary. In primary alkyl halides, the halogen atom is attached to a primary carbon atom. For example, ethyl chloride is a primary alkyl halide. In secondary alkyl halides, the halogen atom is attached to a secondary carbon atom. Isopropyl chloride shown here is a secondary alkyl halide. In tertiary alkyl halides, the halogen atom is attached to a tertiary carbon atom. For example, in tertiary butyl chloride, the chlorine atom is attached to a tertiary carbon atom. You need to be able to recognize allylic carbons. Allylic carbons are carbon atoms bonded to a carbon atom that is doubly bonded to another carbon atom. As the illustrations here show, allylic carbons are one position away from a double bond. Allylic carbons are sp3 hybridized. Allylic haloalkanes have halogen atoms attached to allylic carbons. In benzylic halides, the halogen atom is bonded to a carbon atom with sp3 hybridization, that is linked to an aromatic ring. In primary benzylic halides, the carbon attached to the halogen has only one carbon-carbon bond. Here are secondary and tertiary benzylic halides. In a secondary benzylic halide, the carbon attached to the halogen atom is bonded to two other carbons. In a tertiary benzylic halide, the attaching carbon is bonded to three other carbon atoms. It will be helpful in your chemistry studies if you can identify vinylic carbons or alkenyl carbons, as they are sometimes called. Vinylic carbons are sp2 hybridized and are double bonded to one carbon atom. The vinylic carbons in two different molecules are shown in the illustrations here. Vinylic halides have a halogen atom bonded to an sp2 hybridized carbon atom of a carbon-carbon double bond. Two examples of vinylic halides are shown here. In aryl halides, the halogen atom is bonded to an sp2 hybridized carbon atom of an aromatic ring, as illustrated here. Learning the proper nomenclature of organic molecules is very important, and it takes a lot of practice. Many compounds have common names as well as systematic IUPAC names. The common names of alkyl chlorides can be found by giving the name of the alkyl group followed by the halide. In the IUPAC nomenclature system, they are named as halo-substituted hydrocarbons. Let's write the IUPAC name of the given molecule. The longest continuous carbon chain has 4 carbon atoms, and hence the root word is but. Since the longest carbon chain is saturated, the primary suffix is -ane. Thus, the name of the parent carbon chain is butane. We then need to identify the substituent and its location. For this, we need to start numbering the carbon chain from the end nearer to the carbon atom to which the substituent is attached. We see that the carbon atom with the substituent chlorine is in position 1. Thus, the name of the given compound is 1-chlorobutane.